Welcome back. Last video for this week, section 17C, optimization. Optimization means we're finding the optimum place, for example, for profit or optimum area, meaning maximum or maybe minimum. If we recall, in quadratics, we've done this before in our quadratics unit, optimization with max and min. We use this x equals negative b over 2a. And the a and b, of course, come from y equals ax squared plus bx plus c. We can also use technology. We've used the graphing calculator to analyze the graph to find the maximum mins before. Now, we will also be able to use differential calculus. Okay, exciting, yeah! Now, a warning. The maximum and the minimum doesn't always occur when the first derivative is 0. It's essential to also examine the values of the functions of the endpoints of the interval which you are considering. So remember back in one of the previous units, we took a look at what local min, local max is. For example, it might look like this. Here we would have a local maximum. Here we would have a local minimum. But this is clearly the graph ends here, by the way, and the graph ends here. This is clearly higher than our local maximum, so this is our global maximum. So if we're looking for maximum, that doesn't matter whether it's local max, global max. It has to be the biggest point, the global max. If this global max or global min are within the interval under consideration, then those would be the answer rather than just the local max or local min. So be careful. You need to analyze your endpoints of any interval that we're considering when we're looking at these types of questions. So we've got a couple ways of testing for that. So first of all, we do consider to find maximum or minimum points. We do actually look at the derivative being equal to 0. So we have the sign diagram test. If at some point our critical value, our sign diagram, let's call that critical value A. If our sign diagram looks like this, remember, that means increasing, decreasing, so we have a local maximum. If our sign diagram at some critical point A is negative positive, then we have decreasing, increasing, and that's a local minimum. Okay, so sign diagram test. Second one, second derivative test. Second derivative test. So we're looking at our critical value of A again, where that critical value caused our first derivative to be equal to 0. If our second derivative is less than 0, so negative, it means that we are concave down, therefore a local maximum. If our second derivative is greater than 0, so positive, that means we're up, positive, up, negative, down, and we have a local minimum. The third test, the graphical test. Graphical test. If the graph shows local max or local min. So this shape. And we can see those places on a graph. Okay, important steps to follow when we are solving optimization problems. Step 1, draw a large clear diagram. Okay, make sure you have a diagram of the situation. It really helps to orient yourself. Number 2, construct a formula that will represent what's happening. Okay, now it should be written in terms of one variable only. It's not great to have two variables in there. Step 3, take the first derivative and find the values at which that first derivative is equal to 0. Step 4, if there's a restricted domain, in other words, you're only looking at a particular interval, then you will need to check those endpoints. The maximum or minimum may either occur when the derivative is 0 at an endpoint or at a point where the derivative is not defined. So we use that sign diagram test or the second derivative test or the graphical test to make sure we have a maximum or minimum. And number 5, write the answer to your question. So following those steps, let's look at a couple examples.